Hello everyone. በዚህ ፕሮብለም ሳይሆን የምንመለከተው የተወሰነ አይዲያ ነው። ምናልባት አንዳንድ ጊዜ ሌፍት የሆኑ ቶፒኮች ስላሉ ማየት ስላለባቸው እየስላሰብኩ ነው። እዚህ ጋር የምንመለከተው ሬዚስታንስ ኦፍ ስትሬት ዋየር ነው። ሶ ፍሮም ናው ኦን ከዚህ በኋላ የምንሰራቸው ኤሌክትሮስታቲክስ ላይ እና ማግኔቲዝም ይሆናል። አስፈላጊ ከሆነ በመሀል እየጨመር ደግሞ ከሌሎች ቶፒኮችም የምሰራበት ሁኔታ ሊኖር ይችላል። Now, of course, here now የዛሬ በዚህ ቪዲዮ more discuss ላደርግ የፈለኩት resistance of straight wire ነው, or simply a current carrying wire have its own resistance. So any wire, if you look deep down, it will have a cylindrical like shape. So of course the cylindrical shape መመልከት ትችላላችሁ. So any wire, if you cut into a certain length L, and of course it will have a cross-sectional area A. So the resistance by definition of a straight wire, the resistance is proportional to the length of the wire. That's the one thing that is the experimental fact that we find in laboratory. So in other way, the resistance also inversely proportional to the cross-sectional area of the conductor or straight wire. So in fact, with generality, the resistance is given by the resistivity of a conductor times the length divided by the cross-sectional area. Here is this more without any dependence of voltage current variation, resistance by Z relation ልናቅ እንችላለን ማለት ነው። So ከዚህ information, what will happen if we double the radius of a conductor? Let's say here is the radius, and what will happen the radius if we double the radius? So what will happen if we double the radius of a conductor? በዛ ጊዜ ምን ይሆናል? Then since without doubling the resistance is simply the resistivity, here the constant resistivity times the length of the wire divided by the cross-sectional area. Now here the area without doubling, the area is simply pi r squared. Now when we double, the new area would be a prime would be, when we double here, when the new radius is twice of the first radius, the area of the newly wired a prime would be pi r prime squared. Here we'd get that 4 pi r squared. Now what will happen? The resistivity of any conductor after doubling the radius will be the resistivity and keeping the length constant here divided by the a prime or the area prime, since the r prime is simply the resistivity times the length divided by, here a prime is 4 pi r squared. In fact, from this relation, r prime is simply rho L divided by 4 into 4 pi r squared. From this relation, we know that this is the resistance of the first conductor R. Now r prime will become r over 4. Here is pi r squared. In fact, by doubling the radius, you will reduce the resistance of a conductor by what? By 4 times. You will reduce by 4 times. And of course, from the above relation, the relation between resistance and the length would be a linear relation. So doubling the length would double the radius, vice versa. So this would help you. In fact, ምናልባት አንዳንድ ቶፒክ ላይ ስላላየናቸው ናቸው. So I will see you on another problem. Bye bye.